Okay, so last section we're going to look at for this week is 2.6. Okay, in the warm-up, we practiced solving an absolute value equation. What makes something an equation? It has a what in it? It has an equal sign. Okay. Today we're going to solve absolute value inequalities. What makes something an inequality? What symbol could it have in it? James?
Greater than.
Yeah, it could have a greater than, it could have a less than, greater than or equal to, or less than or equal to. So it's just like absolute value equations, except change that equal sign to one of the four symbols I just said. So let's take a look at an example of where absolute value inequality would make sense. Okay, we're just going to look at this part. Okay, you don't have to write this part down on your guided notes. Okay, so let's say that on a winter night, the temperature always was within 5 degrees of zero. Okay, always within 5 degrees of zero. So what would that mean? If the temperature was always within 5 degrees of zero, what's the warmest I'm basically saying that it could have gotten? Yeah?
5 degrees.
It could have gotten as warm as 5, right? And it could have gotten as cold as what?
-5.
-5. Okay. It's always within 5 degrees of zero, either +5 or -5, right? This kind of situation could be represented just like this. Any number that you can think of in this area definitely has an absolute value of less than 5. Because remember, absolute value really means the distance from 0. So if you measure the distance from 0 to 5, the farthest you'll ever be away is 5. And if you measure the distance from 0 to -5, the farthest you're ever away is also 5 units. So you're never more than 5 units away on either side. And if you want to talk about how far away you are from 0, that's exactly what absolute value is. Distance from 0. So that's an example of an absolute value inequality that would represent this kind of problem. All right. So we're going to look at solving these. This one already kind of has x by itself. It might not always have x by itself. So let's look at how we solve an absolute value inequality. Okay, there's 3 steps. Okay, so step 1, you guys have part of this written. Okay, you're going to have to write the next part. Get the absolute value bars by themselves on one side of the inequality. Okay, what inequality symbol are you going to have? I don't know. It depends on the problem. You could have any one of those 4. Okay, but get the absolute value bars by themselves on one side of the inequality. Sorry. I don't know why it skipped a little bit. There you go. Okay, so what step 1 basically means is we're looking for something like this. Absolute value, I'll just make up some numbers. 2x plus 3 less than or equal to 10. That's a problem that's good. It's ready to go to do step 2. There's nothing else on the outside of the bars messing us up. Here's a problem that's not ready for step 2. Now you added a plus 3. That's no good. You've got something on the outside of the bars that we don't want there. So the first step would be to get rid of this plus 3. And the way you get rid of it is you do the opposite operation. So like in this one, it says if you need to do any addition or subtraction, In this problem, you need to. There's a plus 3. The first step would be this. Minus 3, minus 3. Now look at the left-hand side. There's nothing left outside the bars. Okay. You can have stuff inside, that's fine. We don't care about that. We just don't want anything outside. Right? So that's an example where you'd have to do addition or subtraction. Okay, I did a minus 3. You might also have to do multiplication or division. Let me show you what that would look like. Right, so here's 2x minus 4 is greater than 5. That's good. That's what you're looking for. But if you had something like this, on the outside you had 10 times, and then the absolute value, that 10 is going to mess us up. We don't want that 10 there. So if you saw it 10 times, what's the opposite of times?
Division.
Division. So what I would have to do, my very first thing, before I can go to step 2, I would have to divide each side by 10. By 10, by 10, and that gets rid of that. Now the left side is perfect.
Oh, you would know because there would be either a 3 plus 3 or like there's just a number outside.
There'll be a number outside the bars.
And that would be.
Yep. You don't want to have a number outside the bars at all. Okay? Inside is fine. You're always going to have stuff inside, but not outside. Okay? So if I skip, let me just show you. That's good. That one's ready to go. Absolute values by itself. That one's good. Absolute values already by itself. Let's see if we got one that's not good that I can show you. Well, if we don't have one, I'll make one up. Okay? But any question on that first step? Okay. So once you know that the absolute value bars are by themselves, which it looks like the ones in the notes, most of them already are, but we'll do one where it isn't. Now you're ready to split it and flip it. Okay. Split, flip. We're used to the split part. We already had to do that when we had absolute value equations. We didn't have a flip part. Okay? Flipping you never do with equations, but we got to do it here. Okay? So, one thing you're going to write down is the original inequality. You're just going to take away the bars. That's it. Just write the original problem exactly the way it is, but just take out the bars. Now, for the other one, this one's a little tricky. We're still going to write without the bars. Okay, there's no bars. But we got to do 2 extra things. We did this in the warm-up. Okay, we made the number on the other side the opposite. I think we had a 6 and we made it like -6, something like that. So we did this. This is the extra step. You have to flip the sign. Okay, so 2 things you have to do when you write this other inequality after you split it. Flip the sign and make the number on the other side the opposite. Okay, we got to do both. Okay, any question on those 2? We're gonna go through some examples. So we're just kind of getting the steps now, and then we'll practice them. Okay, and then the last step on a lot of problems is going to be to graph it. Now, the graph is going to depend on what the original problem was. Was the original problem a less than, or was the original problem a greater than? Okay? That's going to make a difference when we graph it. So we're going to have to go back and look at the original. Okay. If the original problem had a less than, we have to choose between the words and or today. We didn't have to choose yesterday because it was just given to you. Right? Today, you have to write the correct word, either and or. If the original problem is a less than or equal to, you're going to write the word and. Okay, and my hint to remember that, think about if you pronounce less than, right? Pronounce it like that. Instead of less than, say less than, right? Just like add a D on the end. Less than and. So think of less than and. If the original problem was great, I'm going to say it like this, greater or equal. Think about if you say it like that. Instead of greater, say greater. Greater is an or. Greater. Okay, so less than, you write the word and. If you have a greater symbol, you're going to write the word or. Doesn't matter if it's greater than or equal. They're both greater. So greater becomes an or. Now, you guys already have this on your guided notes, but don't forget the rules for graphing ands and ors. Ands usually point at each other. You shade between. Ors usually go in the opposite direction. We did that yesterday. Also, if you ever multiply or divide by a negative, that rule still applies. You've got to flip the sign. Okay, that rule doesn't go away. It's there all the time. So let's, I think that's it for that. Now, let's take a look at an example. Okay, do you guys already have the example written, or do you have to copy it? You have to copy it, okay. Okay, so 1a. Absolute value of x minus 5 is greater, so you should already kind of know what word we're going to be writing down at the end. You don't have to write it yet, but greater than 7. Okay, let's look at step 1. Get the absolute value bars by themselves. Blake, are the absolute value bars by themselves there?
No.
Okay, what's next to the absolute value bars then?
The sign.
The sign is okay. You got to have a sign in there, so the sign is okay. Then no?
Sure.
You're confusing me.
I'm confusing myself too.
So let me ask it again. Are the absolute value bars by themselves?
Yeah.
Yes. If there was a number like this, the answer would be no. If there was a number like this, let's say 8 times, then the answer would be no. There's nothing on the outside of those bars. So step 1 is done. There's nothing you need to do to get the absolute value bars by themselves. Okay, so what's step 2? We're ready for step 2. Split it. Split it and
Kill it.
flip it. No, don't kill it. Split it and flip it. Split it and flip it. Anyone think they can tell me what the first one is going to be? That's the easy one. Yep.
X minus 5 is greater than 7.
Perfect. X minus 5 is greater than 7. And now I need my second one. Okay, remember the second one. You've got to do 2 things. After you get rid of the bars, flip opposite. Kelsey?
X minus 5 is less than, negative 7?
Perfect. So she got rid of the bars, just like it says to. She flipped it and made it the opposite. Now, one other thing we should put is the word. Because sometimes if you save writing the word for the end, you forget to do it. Is this an and or an or? Right? Greater. Greater, right? Becomes an or. So at least if you write it right now, I would give you credit because you remembered to write it. Even if you forgot it in the very end, you wrote it right there. So I know that you know it's an or. Okay? Now we solve it. anytime that you split it, okay, whether it's an and or an or, it's going to be exactly the same steps to solve on each side. So, Olivia, how do I solve what's on the left?
You got to add 5 to both sides, and then that cancels out, and then that would be x is greater than 12.
X is greater than 12. Or, how am I going to solve, Blake, how am I going to solve the one on the right?
You're gonna add 5 to 7.
Add 5 to
7, negative 7.
negative 7. How about Aileen? What's negative 5 plus 5? 0. How about Lucas? What's on the left side now?
X.
X. Okay. And how about Leilani? What's on the right when I do negative 7 plus 5? Negative 2. So this whole thing is my answer. X is greater than 12, or X is less than negative 2. Okay. Any questions on those steps? What, like why we did an or? How come it wasn't an and? Anything like that? Okay. When I graph it, what does an or normally look like?
Going out.
Going out, right? We shade opposite directions. So, let's see, I'm gonna number my number line. I'm gonna go by 2s, otherwise I don't think I'm gonna have enough space. So let's go.
Or you can just put 0, negative 2, and 12.
1.
Yeah, you wanna remember though, make sure when you number it, you're consistent with your scale. Like you can't, don't write this down. You can't do that. Because you're saying from here to here is 12 units, right? And then you're saying this is only 2. And I'm looking at that and I'm like, well, they look the same width to me. Why are you saying one is more than the other? So, I think the way you should do this one is like this. Let's go negative 2, 0, 2, 4, 6, 8, 10, 12. That works. Now, every one of them is 2 apart. That is exactly the same as that. They're all 2. Maya, what kind of circle on 12?
Open circle.
Open. And shade to the...
That way.
Which way?
That way. Yeah.
People watching won't know which way that way is.
The left.
Right.
The right.
The right.
The left.
Oh, wait, no, that's mine.
Nope, to the right.
They don't know which
Remember, x is greater than 12. It's pointing to the right. Think if you made an arrow out of that. Shade to the right. How about, Tristan, what kind of circle on negative 2?
Open.
Open. Shade which way?
To the left.
To the left. Yep. Perfect.
Why would you shade out when both of them are pointing in?
Oh my god.
What do you mean, like?
Well, I mean, like.
Well, I mean, I could write them in this order.
I get it. No, I know you see that. Oh, I get it.
You get it?
It makes so much more sense now.
The reason that it looked the way it did is because this one, I'm actually graphing over here, right? And this one, I'm actually graphing over there. I didn't have them matched up with where the picture was. But that's just because of the way I solved them. Does that make sense? You good? Okay. I'm going to erase that because it looks confusing with all those extra lines. All right, so that's that one. Let's take a look. I want to change this one a little bit. Let's try this one.
What?
Yeah, I guess I have a question.
Nope.
Because pretty much everything you're whispering is being picked up by that like $200 microphone.
You're gonna get a lot of views.
You're right under it too, so it's like right there. All right, so
I'm watching that.
look at this one.
Everyone should watch it.
Step one is to make sure that that absolute value is by itself. Is the absolute value by itself here? No, you're not going to have a lot of these, but sometimes I'm probably going to give you at least one of them on the test. Why isn't the absolute value by itself?
Plus 8.
Right, we've got this plus 8. So how do I deal with that plus 8?
Ooh.
Yeah?
Minus 8.
Right. First thing I've got to do,
Wow.
when I put a box around right there, get that box by itself. Okay? Get rid of that plus 8. Minus 8. Minus 8. This actually is the same problem I had on the board before I changed it. Okay? It's going to end up being the same thing, because I think I had a 2 on the other side. That's exactly what's going to happen. 8 minus 8 is gone. How about, Jamiana, what's on the left side now?
Just 4 minus x.
What else?
Greater than less than 2.
A little bit more than that on the left. I see something above that you didn't say to write down below.
Absolute value.
Absolute value, yes.
Absolutely.
Till we split it, those absolute value bars aren't gone. Sign, flip it or keep it the same? Keep it. What did I do on each side?
Flip it.
What did I do on each side, Joe?
Wait,
I subtracted 8.
yeah, okay, I'm fine.
Is subtracting 8 a rule for flipping?
No.
No.
Oh.
Subtracting is never a rule for flipping.
Okay.
10 minus 8 gives me
2.
2. Okay. Now, is the absolute value by itself?
Yes.
Yes. So now we're ready for step 2, which is
Split it up.
split it up. Split it, flip it. Jaden, can you tell me what my first inequality would be?
4 minus x is greater than or equal to 2.
Perfect. So all he did was take the original problem, get rid of the bars. Now the other one. This is where you got to remember to do 2 extra things. Kelsey?
4 minus x is greater than or equal to. No, less than or equal.
Yep. So she flipped it. Less than or equal to?
Negative 2.
Negative 2. And let's put our sign in so we remember that. And? Or is it going to be an or?
Or
Why?
It's greater.
Greater, right? Greater. So that's a greater. Put the word or, now you're covered, you at least got that right. What is it?
alligator.
There you go. However you can remember it, whatever works. All right. All right, what do I have to do to get x by itself on the left? Joe?
Add 4.
All right, if I add 4 and add 4, what's 4 plus 4? 4 plus 4?
Oh, wait a minute. Yeah.
No, 4 plus 4 is not 0. It's 8.
Yeah, sorry. Yeah, negative.
So you want to change your mind?
Yeah.
What do you want to do?
Negative 4.
Negative 4, subtract 4. And subtract 4. Blake, what's 4 minus 4?
0.
0? Olivia, what's on the left-hand side?
2 minus 4.
That's the right.
Oh, oopsies. X. Negative x.
Negative x. Again, I subtracted. We already said you never flip when you subtract. 2 minus 4. How about Kayla? Negative 2. Okay. Is x by itself? Lucas?
Well, there's a negative sign.
There's a negative there. I don't want that. That has to go away too. Now, when you just have a negative, that's really like having what? A negative
1.
It's almost like a negative 1. How do you get rid of a negative 1 right next to the x?
Add it.
Nope, you can't add it.
Divide it.
Divide it. What do you divide by?
Wait,
Negative
really?
Mhm.
Wait, Mr. Hager. At my old school, they taught us like if the letter thing was negative, then we would just move it to the
Well, they were
number.
wrong.
So like if it was like a negative, yeah, because if it was like a negative x and like let's say like a positive 4, then it'd tell us the switches it'd be a positive x and a negative 4.
That's kind of what happens. Basically, when you divide each side, it changes the sign of each side.
Yeah, that's
Yeah.
Explain this to
So here we've got -1 divided by -1. That's gone. What's on the left now? X. I like that. What should I do before I even get to the other side?
You're fine.
Blake, what should I do? You notice I keep calling you Blake?
I wonder why.
That's my first step. My next step is demerits. So, what should I do before I go to the right-hand side?
Switch the sign
Why?
because you're dividing by negative.
Yep, because I divided by a negative. So I get x is less than or equal to, what's -2 divided by -1?
2.
2. So it is basically like the negative just canceled from each
Do you need
side.
to do that extra step or could you just do?
As long as you end up with that, that's fine.
Okay.
Yep, x is less than or equal to 2. Or, how
Why'd you
about,
flip it? Oh, because it was divided by, okay.
yep, because we divided by a negative. Steven, can you give me my first step on the right?
Subtract 4.
Yep, good catch. Subtract 4. That's gone. It's kind of similar to the last one. We got -x is less than or equal to, what's -2 minus 4? How about Julia? -6. And what's my last step? Yep, what are you going to divide by? Yep, divide by -1. All that really does is change the sign of each side. So the -x turns into +x. The -6 turns into +6. What about my sign?
Flip it.
Flip it. Why?
Because you divide by a negative.
Perfect. So we get x is less than or equal to 2 or greater than or equal to 6. All right, let's do our number line. 0, 2, 4, 6. What kind of circle on 2? Princess, what kind of circle on 2? Closed? And Mackenzie, which way do I shade from the 2? Yep, it's pointing to the left, so we're going to shade left. What kind of circle on 6? Yeah, closed. And we're going to shade to the,
Right.
yeah, that's what usually happens with ors, right? They usually go opposite directions. Any questions on that one? All right, so we did a couple graders. Let's try a less than. I'm gonna have you guys try that one. That's a 6. Sorry. Okay, so take maybe like minute and a half, and see if you can do this one. Okay, so remember, go through all the steps. Make sure the absolute value is by itself, and then if it is, go ahead and split it into 2 problems. And don't forget the word you got to put in between the 2. So we'll do this one. Then we got one more we'll do together. We'll go over the rules for the take-home test again, just to make sure everybody's clear on that. And then we might have time to do like a little bit of extra examples. And if you finish them, I'll give you the homework early. Well, no, actually the homework's a take-home, so no, I'm not going to do that early. We'll just do some extra examples, and that'll be it for today. Yeah.
I have the extra credit.
Yep, if anybody else does want the extra credit, just make sure you ask me, and I will give that to you.
For both the less than.
All right, so example 2, a little different than example 1 because of the less than, right? Think of it that way, less than symbol. Okay, first question. Elizabeth, is the absolute value by itself? Yes. I'm looking at the left-hand side. I don't see any other numbers out here, over here. We're good. So, because the absolute value is by itself, Maya, what does that mean I'm ready to do?
It means you're ready to start the problem. So you gotta add 6 to, no, you gotta
No.
you gotta like put the little thing right there, and then you gotta separate them.
Right, you gotta split it.
Split.
Yeah.
Split it up. How about, yeah, Aileen, did you, after I went through it, did you get the right?
Well, I didn't
Original?
finish this one, but I know what I have to do now.
What
I
would you
didn't
put
finish
here?
writing it down. So you do x minus 6, and then without the bracket, you put the greater than, no, less than
Less than.
5.
Yep. So x minus 6 is less than 5.
Yes.
And James, did you get the other one that it splits into? What'd you get?
X minus 6 is greater than -5.
So x minus 6 is greater than -5. Okay. One other thing I should do right now so I don't forget.
Flip this.
Yep.
Or. All right, or.
You're on the right track, but that's not the right word this time. And.
Oh, wait. I thought.
Less than. Right?
Oh.
Less than. Greater. Greater is an or. Okay. So what's my same step on each side? Yep. Add 6.
I wrote in.
Add 6. Olivia, what's on the left side now?
X.
And
11.
11. So x is less than 11.
I was so close. I just wrote it wrong.
Any question on that part? So we got x is less than 11. And add 6. Add 6. What's my other inequality? I know x is less than 11, but it's also
Greater than 1.
greater than 1. Perfect. So x is less than 11, and x is greater than 1. Does that make sense? Think about it as an and. Can you pick numbers in your head that are smaller than 11 and bigger than 1?
Yes.
Yeah.
There's 10 numbers in between.
Yeah, or even decimals, or you can do that too. Okay, number line this time. I'm gonna go by 2s, and this is one somebody had asked, do you need 0 on a number line? I don't have to, but for this one, I think 0 would make sense to put it. And did I go high enough? Yeah. What kind of circle on 1? Wait, you okay?
Just a little bit circle. Just a little bit.
Yeah, hold on, please. Yeah, it's yeah.
Okay, I'm reading that in motion.
Like,
I noticed you're a little excess energy today.
how does ADHD?
He had sugar for breakfast.
I don't eat breakfast.
Throwing things at Lucas.
I toss a piece of gum.
Lucas.
You eat 10 pieces of Red Hot gum for breakfast lunch and
So,
dinner.
Steven, can you tell me again what kind of circle?
Open circle for both of them.
Open circle for both.
Correct.
11?
And 1.
And they both are going, like, both in.
In, right? Because it's an and.
No.
Balance. Bad.
Shade between.
No.
Okay, yeah,
Oh,
Lucas.
that fucking teacher like made this way more.
Hold on, I can't hear you. Other people feel like they're more important than you.
Mr. Chris.
They can't even complain about their math lab. Our math lab is so hard.
We can't even talk.
Who do you have?
We can't even talk.
Trunky.
We can't even talk.
Oh, I heard Miss
I
Charlie.
got a math lab.
And talk, you say one word, threatens with the demerit.
I
People-
was in,
people
I was
say
in
that's in my math
the other one.
Look at some fist fights.
And then I failed to set it as a key I need
We
to
can take
quit.
it up, sorry.
You tell
You're
me I
gonna go
have to
outside.
quit.
No,
I'm gonna send you outside to the deans.
Mr. Chris taught it a different way, but I forgot how he taught it. He taught it like,
He made you switch the signs.
Yeah, Mr. Chris was like.
he made, like, it was kind of the same way, but like, he
It
made
was.
like
I smell spaghetti.
different, like, we didn't have to write and or.
So
Like
there's,
that.
yeah, there's different ways to explain it. I try to explain it, which I thought was like the simplest by giving you those steps. But some people might like the way somebody else explains it better. So it just depends. If you have a method that works for you and you learn something a little different, I would say go with what you know that works for you. Alright, so let's look at our last one. Alright, example 2b. Okay, so first question, is my absolute value by itself here?
No.
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 So this is kind of like 1b. It's not by itself. What's there that I don't want?
3.
The 3, what operation is it doing with the bars?
Multiplication.
It's multiplication. You could put the dot, you could leave the dot off, it doesn't matter. So how do you get rid of a times 3?
Divide
By what?
3.
Perfect.
I'm not gonna say anything else.
Divide by 3. Now, did I divide by a negative?
No.
No. If I did, I would actually flip it right now. So it can end up getting flipped in this problem several times. But this time divided by a 3. So that's gone. Now we just have to do out what's on the right hand side. Question, yeah?
So if you flipped it, would it become an or?
Yeah. You base whether it's an and or an or once you have the bars by themselves. Okay? Once the bars are by themselves. Right? You can't look at the original problem always and say, oh, it's less than, it's an and. Well, if this was a negative and you divided by a negative, well, now when you flip it, the bars are by themselves, it becomes an or. So this is the step you would look at to see if it's an and or an or. Right? So it's just a little tricky when you don't have the absolute value bars by themselves. Get the bars by themselves first. But this time we divided by positive 3, so no flip. Okay. Are the bars by themselves now? Yes. Okay, now we're ready to split it. What's my first one? Oh, Joe?
12 minus x is less than or equal to 9.
Yep. Good. And my second one. Yeah, go ahead.
12 minus x is greater than or equal to -9.
Yep. So he did two things. Split it. That's a 9. He flipped it and made it negative. Same 2 steps on each problem. What's going to be the first step to solve this one?
Subtract it.
Yep, we're going to minus 12. That's gone. Now you have negative x is less than or equal to -3. Last step. Same as the problem. I think we did one like this earlier. Yeah, James?
Divided by -1.
Perfect. Can someone tell me what that's going to give me for my final answer for that part? Lucas?
X is greater than or equal to 3.
Perfect. Now, something I forgot to do, but I haven't finished the problem yet, so I'm okay. What did I forget to write down? It's okay that I forgot because I remembered now, but if I forget the whole time, then that's a problem. Yep. I forgot to write the and. Okay. So make sure at some point you put the word and. I try to remember to do it right when I split it. This time I forgot. Okay. Now when we solve the second one, same way. Minus 12. Minus 12, minus 12. What's -9 minus 12? Yep.
-21.
-21. And my last step, it's the same you just did, divide by -1. So what do I get for a final answer on this one? Yeah, Joe?
Positive 7. X is greater than or equal to positive 7.
X is, first deal with the sign, what do we gotta do?
Oh, sorry. Less than.
Yep, we're gonna flip it. And it's -21 divided by -1.
Positive 7.
What happens when you divide by
yeah,
-1?
Never mind. Yep. Positive 21.
Positive 21.
The green one.
What should I go by on my number line?
3.
Yeah, I'd go by 3s. I think if you even go by 2s, you wouldn't have enough. This is one that I don't think you need 0 on the number line. Okay? If I just start at 3, 3, 6, 9, 12, 15, 18, 21. Perfect. Just go by 3s. What kind of circle on 3? Closed. 21? Closed. Shade where?
Inside.
Inside, right? It's an and. Maybe that would trigger you to remember to write and or, because if you get to the graphing part and you haven't written and or yet, then you'd be like, wait, I don't know if I should shade inside or outside. So figure out if it's and or, and then you'll know. Okay, is there any question on that? All right, so let's just go over again for the video about the take-home. So test tomorrow, 2 parts. Okay, I think it's like 12 or 13 questions. First part, you guys are going to do as a take-home. That is due by 7:45 a.m. Okay, somebody today came up to me, brought something in at 7:50, and they said, "Oh no, am I late?" And I said, "Well, if that was the take-home, yes, you would be, because 7:50 is after 7:45. But I said, don't worry, nothing's actually due today. So it's tomorrow. Okay, so take home tomorrow, 7:45 a.m. If it is late, it's a 0.
I was like a minute late.
Then you die.
Don't be a minute late.
I'll try not to be late.
Then you die.
Come a minute early. All right? Now, I said that if you are in ROTC, ROTC, I will give you till 7:50 because you have your formation tomorrow morning. Okay? Other than that, same rules. Okay, guys, I need people. Pay attention. Joe, please stop talking. Lucas. Okay, make sure you give the test directly to me. Don't say I give it to somebody in the main office by 7:45. Nope. If I don't have it, then I don't have it. It's a 0. Don't. I told you, do not put it under my door.
Wait, what if you do that and you still get it under your door? Will you still take it?
Or will you use recycle?
Give it to me directly.
Yeah, but what if like you're not here and it's you're ready to go to class?
Sometimes I'm real tired in the morning and I see papers on the floor and I'm just like, and I just throw them all away. So it might just get thrown away.
What if I take it to your door?
It might get ripped down by somebody and thrown away. If you are absent, okay, you still have to get it to me by 7:45. If you trust somebody with it and they forget to give it to me, it's a 0. If you email it, that's probably the best way to do it if you are absent. Take a picture of it, email it, you're good. So, if, for everybody that is in class right now, if you take part 1, all of these rules apply to you. If you don't like those rules, you don't have to take part 1 then. You can do part 1 a different day, either in class, before school, after school, or during a study hall. You can do part 1 some other time. Okay? So, and this is your last academic test of the academic term. Okay. Is there anybody that is not taking part 1 now? Yeah, because you were absent, so that's different too. Anybody else besides Sophia that is not taking part one? Okay. Does anybody have any questions on any of these rules?
Can I have the test?
I'm gonna give you the test in, yep, like 1
We
minute.
also have the extra credit.
Yep, if you want that, I will give you the extra credit as well.
I already have it.